This video covers Trig 1.6 or Pre-Calc 4.6. The topic for today is talking about graphing tangent and cotangent graphs. So if we take a look at our first example here, I want you to graph the graph y equals tangent of x. So we can change that to y equals. Now if we are going to graph this, it's going to be a little bit different from the way we graph the sine and cosine graphs in the last video. When we graph the tangent graph, here's the generic form, very similar to the sine and cosine. We just changed the word to tangent. But a couple of our formulas are going to change. A is going to stay the same. It's still the amplitude is the absolute value of A. The period now changes to pi over b. It is no longer 2 pi over b anymore. Phase shift is c over b and vertical shift is d. Those are the same, but they really don't come into play at all. Because in order to get the phase shift and the vertical shift, instead what we do is we calculate the vertical asymptotes. So this is something that's new here, the vertical asymptotes. And the vertical asymptotes are the places where the graph does not exist. And once we have these lines, these vertical lines, that kind of gives us a boundary to trap the graph in between. And so that's what we're going to be doing when we are plotting these vertical asymptotes. And so you'll notice that the equation is the bx minus the c portion of the equation up here that we set equal to negative pi over 2 and positive pi over 2. So let's go through and plot some of these, or not plot these, but find the amplitude, period, phase shift, and vertical shift of this graph. So again, if you just list your formulas off to the side, remember that our period has changed to pi over b now. And in this problem, my a value, which is the number in front of the tangent, would be 1. My b value, which is the number in front of the x term, is also 1. I've got an imaginary 1 here. And then for this graph, I don't have a c or a d, so there is none, because there is nothing that I'm adding or subtracting from the end of x. And then finally, there's nothing that I'm adding out here to get the d value. So the amplitude is going to be 1. The period is going to be pi over 1, which is just pi. The phase shift and the vertical shift, I don't have those. So the next thing I need to do to be able to actually start to graph it is find the vertical asymptotes. So I'm going to use the equation bx minus c equals negative pi over 2, and then bx minus c equals positive pi over 2. Now for my problem, my bx minus c is really 1x minus 0. Or in other words, it's just x. So right away I'm able to find my asymptotes just by recognizing that I just have x there. And so this would be 1x minus c also, which is just x equals 2. So my vertical asymptotes would be what I'm circling here. Negative pi over 2, and shouldn't write it like that, and pi over 2. So that goes on this line here. So what I'm going to do on my graph here is I'm going to put a negative pi over 2 and positive pi over 2, and I'm going to draw my vertical asymptotes. So dashed lines going through those points, because my graph will not exist there. Once you have that, the tangent graph is so much easier to graph, because here's what you need to know. The tangent graph, the basic shape of the tangent graph, looks like this. It's going to be a curve that kind of is almost like an S shape, where the right side is rising and the left side is falling. So the only thing I have to do once I find these two vertical asymptotes is figure out where the middle of this graph would be, and then make the right side go up from there and the left side go down from there. So this graph is pretty easy to find the middle. It's 0, 0. Then I make the right side rise, and I make the left side fall. So you may want to write over here, right for tangent rises, and left falls. And that's exactly what the arms of this guy over here is doing, is he's raising his right arm, he's putting his left arm down to make that shape of the graph. Now what we want to do to get our next cycle, or our next period, is add our period to this pi over 2. So if my period is pi, I'm going to do half pi plus 1 pi, and I'm going to get 3 pi over 2. So that's going to be my next vertical asymptote. And then I can find the halfway point in between. The halfway distance from half pi to 1.5 pi would be 1 pi. And then I make my graph rise to the right, kind of curve and go down to the left. So if we think about this graph in terms of the domain, the x values are working, what you should be noticing is that all the x values are working except for where we have these vertical asymptotes. And these vertical asymptotes are going to occur if we started at pi and we if we started at pi over 2, I'm sorry, and we added a pi to that, and we add a pi to that, and we add a pi to that, or we subtract a pi from that, and we subtract a pi from that, and we subtract a pi from that. So we would say that it's pi over 2 plus or minus some multiple, which we'll use as n, of pi. That would be the x values that would work. The range, on the other hand, since the graph is continuously rising here and continuously falling here, it would be all real numbers for the range. So the next concept that I want to talk about is a concept of what the amplitude will actually do to our graph. If the amplitude is greater than 1, it's going to stretch the graph vertically, which means it's going to be not as curvy of a graph, but you're going to have a graph that will be more like this. Now when a becomes less than 1, so when it's a fraction, like for example 1/5, what's happening is the graph is being more compacted. So think about it, if you were to take and push this end down and push this end up, what would happen to the graph is the graph would be more like this. It would have a much bigger curve to it. So this is when a is less than 1, whereas this is when a is greater than 1. And you have to, when you graph these, you have to decide whether the graph is going to be curvy or if it's going to be more kind of stretched out. And then finally, if you end up having an a that is negative, like this one down here, it's just going to reflect the graph. And so when it reflects the graph, when a is negative, so when we have a negative a, the graph, instead of rising to the right and falling to the left, it's going to go the other way. The left side is going to rise, and the right side is going to fall. And so it just reflects the graph, like it says here. So if I think about graphing these, what I want you to do is to get out 3 different colors to graph each of these graphs in. I know that from the previous example that I'm going to have pi over 2 and pi as negative pi over 2 as my vertical asymptotes, because my b and c and d are all the same from the previous one. If we were to graph a 5 tangent of x, so let's do this one in red. If you were to graph a 5 tangent of x, that's an a value that is greater than 1. That's going to really stretch your graph out. So our center point would be here. Our graph would really be stretched like this. Now, on the other hand, if I changed my a value, I'll do this one in green, to a 1/5, what that will do to the graph is it will kind of hug the axis a little bit before it decides to go up. It'll make it much more curvier. So it'll hug the axis down here and then it'll drop down. So my graph will look more like that. So this green graph is when your a is 1/5. So you kind of hug the axis a little bit and then drop down or rise it up. And finally, if your graph has a negative 5, so the 5 means it's going to be really stretched like this red graph is. But the negative 5 means that it's going to go the opposite way. It's going to rise to the left and fall to the right. So it'd be a graph that would look more like that. Left goes up, right side now goes down. And it's going to be very stretched out. So the left side would come up like this, and the right side would go down like that. Again, it's much more stretched out than the green graph would be. So when we're graphing the a's, we have to determine how stretched out or how compacted they are based upon whether the number is greater than 1 or less than 1. Okay, so let's actually graph a tangent graph. So if it's helpful to you to write this out as a tangent of bx minus c plus d, go ahead and do that. I'm going to take the time to actually change this to 1/2 tangent of half x, so that I recognize that my b value is 1/2. And my a value also is 1/2. And then I don't have a c and a d value, so those are both 0. So now if I think about the amplitude, the absolute value of a, period is pi over b, phase shift is c over b, and vertical shift is d. I already know these are both going to be 0 because I don't have a c and a d. The period is going to be pi over 1/2, which is really going to be 2 pi. And then the amplitude is a positive 1/2. And really what that will do is that will make the graph be much more compacted. So when I make my graph, I want to hug the axis a little bit before I start to rise and before I start to fall. If I find the asymptotes, the bx minus c equals pi over 2 and negative pi over 2. When I do this, my bx minus c for my problem is 1/2 x. So to get rid of the 1/2, I'll times by 2. And I'm going to get pi to be one of my vertical asymptotes. If I do it again, if I times by 2, I'm going to get negative pi to be my other one. So again, if I plot those, negative pi, positive pi, and make my vertical asymptotes go through that, that already gives me my starting and stopping points, and it tells me where I should be making my graph. So just so happens that the middle of this graph again is 0, 0. And what I know about this graph is that it should hug the axis a little bit and then go up because of the 1/2. Hug the axis a little bit and then stretch down because of the 1/2. Now if I want you to make another period, which I always do, I always want you to have 2 periods, what you would do to get your next vertical asymptote is add the period on, 2 pi. So if I take pi and I add 2 pi, I end up with 3 pi. So that's going to be my next vertical asymptote. I need to break this up into the halfway point. The halfway point between pi and 3 pi would be 2 pi. And then I can go ahead and hug the axis and then rise, hug the axis and then fall. And that would be my 2 periods. Now I could have made my period go this way if I wanted to. I chose to make mine go in the positive direction.